Hello, everybody, and welcome. I invite you all to hear the story about how Wix tackled the Monorepo migration like a tech giant. A bit about myself. My name is Zachi. I'm married to Irit and a proud father of two kids, trying to get them into technology, but currently they are into dinos and dancing. I've been at Wix for the past 5.5 years, started in a Basel team, and currently in the CTO office in DevEx. I'm really into Raspberry Pis. They are like small candies, if you're familiar with. A passionate technologist and open source enthusiast. Now, a few projects I was involved in at Wix were Monorepo, virtual Monorepo, local development, IntelliJ Bazel plugins, Angeflow migrations, and others. Now, a quick show of hands. How many of you actually worked on a single Monorepo? Nice one. I hope that until the end of this talk, you will learn about what Wix is using today, which is the virtual Monorepo, why we want to transition to a real Monorepo, and our journey towards the Monorepo both in CI and local. Now let's talk about the common developer feedback loop. This is something that you should be familiar with. You clone a repository, you push your code to a PR after working locally, of course, and then on CI, you fetch the Monorepo code, not you, the build agent itself, fetch the Monorepo, maybe or maybe not, optimizing the build settings and starting a build. It's a rinse and repeat process until you're fine with it, all of your changes are inside, the build is green, and then PR and merging to master. I want to share with you what Wix is using today. Today, first, around 2018, Git didn't have large-scale repository support. So Wix created a proprietary solution, which is called VMR, Virtual Monorepo. And it helped us to use the Bazel build system, which is an open source build system that came out of Google, in a virtual way. And what it did is helped us clone 60 smaller virtual repositories into a single one, allowing you to work on a monorepo, but virtually. Now, the issue was, and still, that developers are still working on a single repository and not the entire thing. And the virtual monorepo had noticeable pains. Some of those are a velocity hit. Why? Because the repository didn't share cache with other repositories. So things got built again and again. So longer build duration eventually. We had to create homegrown set of toolings just to glue everything together. There were missing features. Think about it. It's a distributed system. So code search, large code refactoring, finding code usages is not that simple. And complexity. Keeping 60 repositories, virtual ones, in sync is not a simple task to do. The VMR still have one major pain point. It's called cross-repo builds. Think about the front-end engineers. Framework engineers. My bad, we are back-end engineers in here. They are issuing a small change, and they want to verify that they haven't broke anything on the entire monorepo. So a small change can lead to 60 PRs, and eventually 60 build agents building those repositories based on that change. So what is the solution? Using a one true monorepo. You build once instead of 60 times. Now, monorepo is a big challenge, and you need to start somewhere. So we've started with exploration. First, talking with other large-scale companies. See what they are doing on that front. Oh, sorry, it's a teaser. Then we had to create the monorepo itself, the Git index, taking all those 60 repositories, combining them into a single one. Side by side, we need the monorepo to live with the virtual monorepo in the testing phase and also later on the migration period. And we took baby steps into an uncharted domain. We didn't know what to expect. So this is the punchline. I've shared some of the Monorepo challenges with my spouse, Irit. And at some point she said, when exactly did we give birth to a Monorepo? So with that in mind, the Monorepo child started to ask questions. Daddy, can we build a full Monorepo? This is the million-dollar question. Now, the naive approach would be, take the Monorepo, throw it on the current virtual Monorepo build infrastructure, and see what happens. What do you think happened? Server crashes, out of memory, no space left on device, and plentiful of other issues. Eventually, we managed to have a full Monorepo build, a green one. We done it by having a specific lab environment. We've scaled up CPU, memory, customized the build command, all kinds of bezel flags, just to make it happen. So even though we made it, the build took around 5 hours. So do you think it was a success? The estimated developer lifecycle based on those 5 hours would be finish the feature, then landing the code changes in a PR, and then waiting for the Monorepo build to complete. And we don't want to get there. I want us to take a look at the scale of weeks back in CI. We have, on the backend Monorepo, 33 million lines of code. The size of the Monorepo is 22 gigabytes. We have 450 backend engineers and 6K daily builds. But it takes 30 minutes to perform git clone on CI build agents. And worse than that, it takes 1 hour to git clone on the local machines themselves. Now, we have 450 backend engineers. Think about it, that each and every one of those are waiting for around 1 hour. And we must set some expectations before we continue on. So, we must have a performant version control to support the Monorepo of any size. The total build duration must be the same or better than what we have today. We don't want a degradation of service. The local development front should support monorepos at any size, because we're thinking about future growth. We'll have more products, more code. So we need to support the future as well. And clone time. We must drastically reduce the clone time both on CI and locally. We have Git challenges, and the question is if they are solvable. Around 2021, Git released all kinds of features that helped users to work with large repositories. Some of those were sparse checkout, sparse index, untracked cache, background maintenance. Do you think it sounds that simple? Upgrade and that's it? It wasn't. Let's dive into it. So let's look at the naive approach of performing a raw Git clone on the build agents. Every build agent perform a raw Git clone directly from GitHub and starting to do its things. There are some challenges. First of all, long clone durations. You saw it takes 30 minutes to perform the specific raw clone on the build agent itself. Slow Git commands, a lot of files, Git status, diff. So those take more time than expected. And IDEs, the latest and greatest advanced features that Git released doesn't always play nicely with IDE. We can surely say that the naive solution won't cut it. 20 minutes to fetch the code, and eventually total time of 5 hours and 20 minutes. On our second attempt, we tried using Amazon EFS, an elastic file system. It's a network drive that is being shared between all the build agents. So we've used Git worktree to have the index cloned on Amazon EFS, and then copy it over the wire into each and every build agent. Now, unfortunately, it didn't work quite well. The clone time wasn't that efficient over the wire, And also, Git worktree has limitations. It doesn't support concurrent work on the same branch. So if we have two builds running on master branch, only one could occur. We can tell that we've improved the fetch code time, down from 20 minutes to 10 minutes. But still, it's not good enough. Around 5 hours and 10 minutes of total time, we need to improve that. Now, this was my aha moment. When you think about it, what is a Git index? It's a text-based, structured data, repetitive information, and small file sizes. It's ideal for compression. So compression allowed us to reduce the clone time down from 20 minutes to 1 minute. How do we do it? We've optimized the git clone command. We've cloned with a single branch, limited history to 90 days, no garbage collection, and we've used all kinds of large repositories support the flags released by Git. We've compressed the Git index, the optimized Git index clone, into a targz down from 22 gigabyte to 2.5 gigabyte. We've uploaded it into Amazon S3, and then on the build agents, we've downloaded it, fetched deltas, and started the build. You might ask yourself, it's amazing, all right, you reduce the fetch code duration down from 20 minutes to 1 minute, but what about the build duration? It still takes 5 hours. So on the next part, I want to share with you how to reduce build durations using target selection. Target selection allows us to build a part of the monorepo. Why? First of all, you build only what matters, only what the user changed, and the targets which are affected by the change. You don't need to build everything. Velocity is increased because you have shorter feedback loops, and the build duration themselves are shorter. You build a part. You're not building the entire thing. Now, we've used BazelDiff. It's an open source project which allowed us to select which targets we need to build. Now, BazelDiff, this is something that we currently use in production on our virtual monorepo. It works great. But the problem is, when using it on the monorepo, due to the large amount of files, it's not that performant. And it takes up to 15 minutes just to calculate which targets we need to build based on the user change. Now, it looks promising. Check out the build duration, down from 5 hours to between 5 to 20 minutes. But we've added a penalty to the optimization stage, an extra 15 minutes every time. Now, think about it. Bezel dependency graph is a graph. So why not using a graph database? We've selected AWS Neptune to be our graph database, and this is how the process went. Identify which sources were affected by the user on the build machine, then query the graph database for which target were affected and which dependents and dependencies we need to build, and build partially instead of the entire thing. We are down from 15 minutes of target selection time to between 1 to 20 seconds, down from minutes to seconds. I think it worked some claps. So, using S3 with GraphDB, we are down in the optimization from 15 minutes to between 1 to 20 seconds. But the big numbers are eventually down from 5 hours into 6 to 20 minutes. So this is a big win for us. Thank you. So are we there yet? Nope, not yet, but we're getting close. We wanted to solve the cross-repo pain that the VMware currently have. Oh, sorry. So we've allowed users to build their actual change in production in the PR on the monorepo itself. We've allowed it using a GitHub commit tag. You work on the virtual monorepo, but you want to test on the monorepo itself. We've enriched the CI build pipeline of the monorepo with just the right information that the users should have for self-service, sorry. And we've reduced the 60 cross-repo builds from a potential of 4 hours down to around 20 minutes. On the next part, I want to share with you the challenges that we are facing on the local development front. Can you guys think what it takes to work on a 22 gigabyte monorepo locally? Think about it, the scale of it. So there are a few problems with it. The Git performance, slow Git commands, as I've noted before, due to the large amount of files. Memory, you won't be able to build the entire thing locally. You'll get an out of memory errors. And IDE, slowness and freezes due to the large amount of files. Now I'm proud to share a tool that myself and the team created just to tackle this challenge. It's called Tapas, and Tapas is the missing link between Git sparse index and Bazel. It allowed us to have a smooth and performant way to work on the monorepo of any size. It also allowed a flexible approach. There is a difference between being a framework engineer and a business-oriented engineer. Framework wants to work on the entire thing, on all the monorepo. But the business-oriented engineer wants to have a specific scope to work with. So we've allowed that. You can work on the partial state of the monorepo locally. IDE integration, seamless integration with IntelliJ and other Wix local development tooling. And side by side, there is an ability to work on the monorepo locally, but sync your changes back to the virtual monorepo, which is the production environment. I want to share with you how to focus on a partial state of the monorepo. Tapas monorepo focus on the target itself, and then automatically you're working on 17% of the monorepo locally. Everything is buildable and testable. You can also add additional targets if you want additional scoping. Let's look on an actual use case a developer might encounter. Let's say I'm a developer from Dev Center and I'm working on upmarket managed apps. I want to work on OpenAI client, which exists on a separate folder, which currently is a separate virtual repository. Those should be buildable and testable. But I also want only to see the sources of server infra of the gRPC call scope. So it's possible. I have something to build, something to see. The tools support that. We also meet you, the developers, at the comfort zone, which you're probably familiar with, the Bazel IntelliJ plugin within IntelliJ. The same environment, the same target that you define, and then everything is automatically set up for you. And it's always nice to get positive feedbacks from our users. Let's recap and about what we've learned today on our journey towards the monorepo. Advantages of real monorepo. The framework team are actually using the monorepo during the last couple of months. They've reduced their work time and changes they are introducing for a matter of days into hours. Optimizing Git usage to support large-scale repository. Reducing the clone time from 20 minutes to 1 minute. 95% improvement. Target selection. We have reduced the total build duration from 5 hours to 40 minutes to 10 minutes. And local dev is possible on a monorepo at any scale. I really hope that you've enjoyed this talk. A detailed blog post will get released later on. And in addition, I have a blog post, and I maintain all kind of open source projects. If you want, you can check the link. Thank you very much.